CCIEORDIE.COM. I'm your host, Artek, and this video will be discussing switching. This is meant to be a brief introduction to switching with a few salient points, but not meant to be an exhaustive dissertation on the subject whatsoever. We'll begin with the hierarchical model, which is presented in the diagram here, comprises the core, distribution, and access layers. The core is used primarily for high availability and fast switching of data, and the core aggregates the distribution layer beneath it, as you can see from the diagram. The distribution layer typically provides inter-VLAN routing, QoS, packet filtering, and other services, and the distribution layer is used to aggregate the access layer beneath it. And the access layer primarily used as an entry point for end-user devices such as PCs and printers. The Cisco Discovery Protocol, CDP, is the Layer 2 discovery protocol proprietary to Cisco for discovering directly connected neighbors. We can see the status of CDP using the show CDP command with no other parameters. You can see that I've set the timer at 10 seconds. It defaults to 60 seconds, and I just don't have the patience for that, so I normally set the timers to be much quicker. You may or may not want to do this in a production environment. If we go to config T, I'll show you how to adjust the timer, CDP timer, and we'll set it for 15 seconds now. And do show CDP, and we see that it's changed to 15 seconds. End here, and let's show our directly connected neighbors with show CDP neighbor. And we can see on the output that we're connected to core 2, disk 2, and disk 1 directly, here and here and here. We're not directly connected to access 1 and access 2, and that's why it doesn't show up. I took the liberty of setting up some interface VLANs that is a little more advanced. We'll get to that in a later video. But I can get around using Telnet 10.10.10.13, and with Cisco devices, you can do that directly from the command line without typing Telnet before the IP address. Anyway, so we'll type the password to that. And I just want to show you, show CDP neighbor, the directly connected neighbors for distribution 1. You'll see it's directly connected to core 1, core 2, and distribution 2, as well as to access 1 and access 2. Now let's take a look at access ports. Config T. And show run interface F0/15. Do show run interface F0/15. We'll see that it really has no configuration. We can change that configuration with interface F0/15, switch port mode access, and switch port access VLAN 15. And that will create VLAN 15 on the fly. If we do show VLAN brief, we'll see that VLAN 15 now resides, or port 15 now resides in VLAN 15. Now let's take a look at some of the trunk ports. Do show interface trunk, which is a great command. I use it all the time. And that's going to show us the state of our trunk ports. We'll see that 1 and 2, which are going from disk 1, disk 2 to the access switches, are set for trunking. And the native VLAN is set for 10. Again, that's something we'll discuss in a later video. And 7, 8, 9, 10, and 11, 12 are the redundant connections between core 1, 2, and disk 1 and disk 2. So that's a brief introduction on the trunk ports. A switch port connected to another switch port creates a single collision domain. And a VLAN is a layer 2 construct that provides an isolated broadcast domain for its participants. Now, just a minute here on span. Do show span. We're on the distribution layer. a couple of things about this is with span, we can see that this is the switch. This is the priority and the MAC address for this switch. This switch is actually the root bridge because it's on top. We can see, let's designate forward. We can see that this is not a root switch or a root bridge because it has a root port. Our root bridge will not have a root port. We can find out, we know that this is the root bridge because it's on top. So if we do a show ARP, and we remember that MAC address CE80, do show ARP CE80, we know that 10.10.10.16 is our root bridge based on the spanning tree information. So if we take a look at, and here, 10.10.10.16, it's going to tell us why. And the reason why is because it has all other elements are equal in the spanning tree configuration, so it has the lowest MAC address. That's why it's winning the election. Show span. And the biggest way we understand that it's the root bridge because it says this is the root bridge. Another way of noticing it is that all ports are designated and forwarding, and there is no root port. So that's a little bit of an introduction on switching. We'll get to root bridge assignment, etc., at some other later time. But do notice that the access to switch is the root bridge, and that is not such great placement in our diagram or in our switch network. So that would be something we'll address with root bridge placement and more on spanning tree at a later time.